Dear students, today I am going to take a very important case of oxo-acid compounds, and all the oxo-acid compound belongs to the sulfur. Here is the H2H2O7. It has common name oleum and chemical name is the pyrosulfuric acid. H2H2O8, its common name is martial acid on the basis of its discoverer, and its chemical name is the peroxidized sulfuric acid. H2SO5, its common name is caro acid on the basis of honor of its discoverer, and chemical name is peroxymonosulfuric acid. And H2SO4, that is the sulfuric acid, this is also called as the king of acids, king of all acids. Now we will see here, in all these oxo-acid compound, sulfur atom having same oxidation number. Here sulfur having +6 oxidation state, here sulfur having +6 oxidation state, here sulfur having +6 oxidation state, and here sulfur having +6 oxidation state. Means in all oxo-acid compound having same oxidation number, then their acidic strength cannot be compared on the basis of their oxidation number. Then on which basis we can compare their oxidation number, their acidic strength? You will see here, there are some bases we can make their structure. By knowing their structure, by their chemical properties, we can find out their acidic strength. Then stay till the end of the video and learn properly. What is first you see here? Here H2H2O7, it has maximum acidic strength. After that, sulfuric acid H2SO4. After that, martial acid, that is the H2H2O8. I want to tell you, H2SO4 and H2H2O8 having nearly same acidic strength, but on deep study you will find out that H2SO4 having higher acidic strength as compared to the H2H2O8, that is the martial acid. After that, here H2SO5 means caro acid. Caro acid having least acidic strength. This is the order. Now we can learn one by one what is the reason behind that. If you will see here H2H2O7, this compound having two parts. One part, that is the H2SO4, and another part, that is the sulfur dioxide. H2SO4 combined with the SO3 to form the H2H2O7 oleum. You can see here H2SO4 have tendency to give H plus and HSO4 minus, means it is the proton donor. And this sulfur dioxide have tendency to react with the water to form again H2SO4. Then what you will find, per unit volume, the concentration of hydrogen ion here maximum as compared to the another oxo-acid compound. Okay, therefore H2H2O7 have highest acidic strength. Now here H2SO4, this H2SO4 gives H plus and HSO4 minus. First of all, it is giving hydrogen ion, means proton, therefore acidic. And here HSO4 minus, that is the bisulfate ion, this is also stable conjugate base. If it is stable conjugate base, then acidic strength automatically increases. Now here H2H2O8, this H2H2O8 having peroxide bond. What is the peroxide bond? When two oxygen atoms link directly by single covalent bond, this is called the peroxide bond, and where peroxide bond is present, it is oxidizing in nature. Therefore, slightly acidic strength decreases as compared to the H2SO4. Now, this is the caro acid. This caro acid also having peroxide bond, therefore its acidic strength also decreases. I have told you that acidic strength directly depends on the number of oxygen atom attached with a double covalent bond, means one of the pi bond and another is the sigma bond. This is the important condition. Now, acidic strength also directly depends on the stability of conjugate base, stability of conjugate base. And the stability of conjugate base directly depends on the number of resonating structure. So then it depends on the number of resonance structure or resonating structure. Now, the another important thing that acidic strength decreases, it decreases when peroxide bond is present in a molecule. Acidic strength more decreases when disulfide linkage is present in the molecule. I assume that you have properly understood the concept. Now I am going to make a structure of these all oxo-acid compound. Therefore, stay in video. Then I am going to make the structure. What is the structure of H2S2O7? H2S2O7. This is the molecule having 2 sulfur atoms, 7 oxygen atom and 2 hydrogen atom. Then 2 of oxygen atom goes with the each of hydrogen atom. Then here this is the sulfur, here OH, this is also OH. And now one of the oxygen atom attached with the double covalent bond, another here also double covalent bond, and the rest one of the oxygen atom in between of these. Means here is no peroxide linkage. Now the another molecule I am going to take, that is the H2SO4. Then what you will see here, same 2 oxygen atom goes with the 2 hydrogen atom. Then here sulfur, this is the OH, one of the oxygen atom bonded with the double covalent bond, another oxygen atom with double covalent bond. Now here also no peroxide linkage. Now here H2S2O8, this is called as the Marshall acid. Now here this is the sulfur, Now here each oxygen atom goes with the hydrogen. Here is the double bonded oxygen, here is also double bonded oxygen, here also double bonded oxygen. Now 2 oxygen atoms still left, therefore they will go in the center. This is called as the peroxide linkage. And now when I am talking about the H2SO5, this is called as the Cairo acid. Then here this is the sulfur, this is the oxygen hydrogen, this is the double bonded oxygen, this is the another double bonded oxygen, and now 2 oxygen atom join with each other like this manner. Therefore what you will see, this is also the peroxide bond. Then we are observing here that how many is the total number of oxygen atoms attached with the sulfur by the double bond. We have to focus on the double bonded oxygen atom, not on the single bonded oxygen atom. Have you got it? Then you will see this is the 1, this is the 2, this is the 3, this is the 4. Okay, and in between of both the sulfur atom there is the oxygen atom. Oxygen is a highly electronegative atom. This is the electron withdrawing atom, and if it will withdraw the electron, therefore the density of electron decreases on the sulfur atom. Therefore sulfur have tendency to accept lone pair electron, therefore it behaves as the Lewis acid. Okay. Now here, this is the sulfur. There is a 2 oxygen atom bonded with the double bond. Okay. And in this molecule, there are the 2 sulfur atom bonded with the 2 oxygen atoms. But here is the peroxide bond. This is called the peroxide bond. This is called the peroxide linkage, which is oxidizing in nature, and it decreases the acidic strength. Okay. Now here what happened? Here also again peroxide linkage, and this peroxide linkage decreases acidic strength of caro acid. So I think now you have properly understood the lecture. We can write here that from here to here, decreasing order of acidic strength. If you properly understood the lecture, then please subscribe my YouTube channel Orbital World, like, share, comment, okay, and keep on your study. Thank you.